they changed my like the buttons and where things were the very end of spring term. And so I'm still trying to remember where they moved everything. I wish they would quit doing that, but it is what it is. So, welcome to Thursday, week one. Today, we are going to be doing section 2.2. This will be talking about histograms. I will tell you like the difference between a histogram and a bar graph. Very minor differences, but they exist. And we're going to do stem and leaf plots and look at shapes of distribution. Then we will go into 3.1 and we'll look at measures of center. We'll look at mean, median, and mode. There are a lot of fun little catchy songs on YouTube about mean, median, and mode. You probably learned about them in about fifth grade. If anybody can remember fifth grade, I think that they were brought up back then. So they probably are things that are in your head somewhere, but you haven't used them in a while. And so I'm just going to bring up some memories, and I'm not going to sing you any of the ditties from YouTube, but trust me, there's a lot of them. And then it's not on the screen, but I'm going to write it. Oh, write it. Maybe if I can get my pen working. Okay. We have, whoa, that's fat. Lab 1. I'm going to change how do I do that? And change the width of my pen. There we go. Let's change it. Let's make it not as fat. Is this better? That's now too skinny. Okay, let's try this. 3. Yeah, that's good. Okay. Anyway, so we're going to do lab 1. I'm going to go over that. I talked about on the end of class Tuesday what you need for lab 1. I will mention it again when we get to that. So we'll do that at the end. I had something else that I thought was really profound and it's not there. It's gone. Okay. I was at the park with 5 grandchildren this morning. So a lot of my brain cells, I think I left them there. They were kind of wild today. I'm glad the weather was a little bit better so that we could go play at the park, but it was a blast. They're so much fun. It was 2 4-year-olds, 2 6-year-olds, and an 8-year-old, but loads of fun. And they're wild and crazy, and I love every minute with them. So, all right. Whoa. Okay. So, okay, I had something else. It's totally gone. Except for my iPad is upside down right now. Give me a second. Okay. So let's talk about real quick. We're going to talk about discrete data. We have frequency tables and relative frequency on Tuesday. When you're using discrete data, we kind of treat the numbers as if they're not numbers. Let me show you. So once again, this is the number of cars people own in their household. So we're not really treating them as numbers. We're just treating them as outcomes, just like we did with the categorical data. And so I tallied up how many people in my sample had 0 cars, have 1 car, have 2 cars in their family, all the way up to 5. And then I just tallied those up, and then we calculated the relative frequency. So I have 50 data values. So you would take the four people that have 0 cars, divide it by 50. So 8% of the people had 0 cars. 13 had 1 car. So 13 divided by 50, 26% of my sample has 1 car. So we're kind of treating it just like it is categorical, even though it's discrete. And someone can say, I have twice as many cars as you do. So you can do math with them. So they're discrete. They're discrete quantitative data, but we still kind of in this sense treat them like they're categorical, if that makes sense. So that's all I was saying about the categorical. This probably was supposed to be on 2.1, but I didn't break them off in my slideshow, so I couldn't remember which was which, so I just left them on 2.2. So there we go. All right, let's talk about histograms. So histogram is very similar to a bar graph. It has rectangles just like a bar graph. And we have the height of the rectangle is the frequency or relative frequency, just like the bar graph. The width of the rectangle of each rectangle is the same. This is the difference right here. The rectangles will touch each other. In a bar graph, this is going to be my beautiful, perfect bar graph drawing. In a bar graph, it would look like this, but in a histogram, it would look like this. This is obviously not the same data set that I'm drawing. So the histogram is on the left, and then the bar graph is on the right. So they're very, very similar. We do use histograms occasionally for discrete data, but most of the time histograms are used for continuous data. And that's kind of the purpose of them, the bars touching each other, is because it's kind of like when I draw the graph of a continuous function, I don't lift my pencil. So the histogram is kind of like the not lifting your pencil. One bar kind of bleeds into the next bar. So it's kind of like the graph equivalent or the bar graph equivalent of that, if that kind of makes sense. So I'm going to first do it with discrete data. Now there's just slight differences with discrete data, and I don't believe that Excel, when they're doing histograms with discrete, I don't believe that they differentiate between discrete and continuous. So theirs aren't going to look exactly how you would want to for discrete data. And I'm going to kind of show you what I mean. So discrete data, when we have a discrete histogram, your the category, each outcome of your variable would just go smack dab in the middle underneath of your the bar. So there were 0 cars, 1 car, 2 cars, and on and on and on. And then the height is the frequency in this case. And so it looks a lot like a bar graph. It's just my bars are touching. So this is specifically for discrete that I would put them in the middle like that. So it's very specifically for discrete. When we're doing continuous, it's going to look a little bit different. And I'll show you what that looks like in a second. So just discrete, you put your each outcome of the category in the middle of the bar. And then this is with relative frequency. It's basically the same bar graph, just one is frequency and the other is relative frequency. So they're pretty much the same. And for some reason, my chat disappeared. I'm going to put that back up. Oh, good. Nobody has needed me. So reminder, I have my chat on my other screen. So if you do send a message through chat, if you send something through the chat, a question or anything, make sure you're sending it to everyone because I can't see it on my screen if it's just to me because it doesn't show up the notification. So if you're sending a chat, something through the chat, please send it to the everyone chat and not the specifically to me. All right, moving on. So classes, I usually call them bins. I'm going to put that word there also. Classes, bins, categories, this is where we group things. So with discrete, it's just going to be, it's usually just one value. But if it was a large number of different discrete values, we would have to create them in intervals. So when I'm writing it, so notice how this number right here is directly in the middle underneath the bar. So it's just in the middle underneath the bar. So that's what I mean by it's in the middle. You're going to see it different when we do the continuous. When, like, for example, let me, okay, try to ignore the numbers underneath here. So let's say that I had like a whole bunch of different values. Let's say that this was something different. And this was from like this bar, the first bar was like 0 to 5. And then the second bar was 6 to, or let's say 0 to 4, and then 5 to 9. So then I would put a 4 here. Wait, sorry, I'd put a 5 here because that's the beginning of the next bar. 0's here. And then the next bar up here would be 10. Then this would be 15. So this is how we're going to be doing it with continuous data, or if we separated the discrete into larger intervals. No, the relative frequency is like a percent. So like let me go back just a second, Alex. So my relative frequency here, it's 8% of the people have 0 cars. So instead of just saying 4 people have 0 cars, I'm saying 8% have 0 cars. So I just put it into a percent or a proportion of the people out of those 50 that have the 0 cars. So it's still discrete. These values are still discrete, but now I'm just turning it into a percent. So I guess technically you can say relative frequency, that number is continuous, but since it's not our variable, I kind of am not even thinking of it that way. Did I confuse you worse? Sorry, is that okay? All right, let's move on and hopefully we can get there. Okay, so as I was kind of showing you, if I had a large number of values, whether they're discrete or continuous, I have a large number of values. I'm not going to put, if I had 0 to 30 in my discrete data, I'm not going to have 30 different bars on my histogram. So I might split it up and say like 0 to 4, 5 to 10, 5 to 9, 10 to 14. I might split it up into intervals. And so these are called creating classes or bins using these intervals. And I'm going to show you what this looks like. And there's not some rule about the size or how you break it up. It's all personal preference. This is the thing that kind of gets people don't like about stats is a lot of things don't have like a specific rule. This is the way you do it. A lot of things is like you go with your preference. As you do things more and more, you kind of go with your preference. And that this is going to be one of those cases. All right. So this data, I hate that. I can't see that. This data right here represents the number of people age 25 to 64 who are currently work disabled. And these are numbers in thousands. This is a lot. So in ages 25 to 34, I have 2,132 people, or 2,132,000 because it's in thousands. Then 35 to 44 and 45 to 54. So what I did is I split them into groups, 10 each. Each of these has to be the same size. Uh-oh, sorry. The way when I break it down, each one has to be the same size. In order for it to make sense and to display our data well, we have to make them the same size. So 25 to 34 is 10, 35 to 44 is 10, and on and on and on. They each have to be the same size. This right here, this number right here is a lower class limit. So the bottom of each of my bins or classes is the lower class limit. So 25 or 35, 45, and 55. Those are all lower class limits. The upper class limit is the largest value in the bin or the class. So this right here is an upper class limit. So however high my value goes, the highest in that bin or class is the highest class limit, the upper class limit. So that's the largest value. So you need to make sure you're separating them into the same size. Okay, so our class width is the difference between the consecutive lower class limits. So in this case, 25 minus 35. So I took this 35 and I subtracted 25. So I have a class width of 10. Questions on this screen so far?
Could you repeat that last? Where did you get the 35 from?
I took this right here, the second one, my second bin, my second class, and it starts at 35. And my first class, I'm going to use a highlighter because I can. So this right here, this 25 is my first lower class limit. And then this 35 is my second lower class limit. So you just subtract those from each other to get your bin width or your class width.
Okay, thank you.
You're welcome.
Do you always subtract the lower class limit, or could you subtract the upper?
It's going to be
Does
the
it
same
matter?
thing. No,
It's
it
going
doesn't
to be the
really
same.
matter.
Okay.
As long as you're consistent, lower and lower and upper, as long as you're consistent. Because
Okay.
I wouldn't take this 44 and subtract 25. That's just going to cause issues.
Right. Yeah. Okay.
So,
Thank
but
you.
unless you want to cause issues, then go for it. Then go for it. All right.
Thank you.
You're welcome. No problem. Any other questions here? Once we actually start putting it into a graph, it kind of is more helpful. But I know it's really hard when everything is theoretical. And I'm never going to make you do make a histogram by hand. You are going to be using Excel. I'll show you how to do that and how to kind of my instructional coach teacher, she calls it zhuzh the numbers a little bit to make it be pretty in the way you want it to be. We're going to kind of tweak things a little bit. All right. Let's go to the next page. So I have a bunch of data here. So this is the time between eruptions in seconds for a random sample of Old Faithful geyser eruptions. So I'm going to make a frequency and relative frequency distribution of the data. Then we're going to make a histogram. Technically, this is continuous because if I am measuring time, in order to get to 728 seconds, I had to hit all of the seconds before it. So this is continuous. Most of the time when we're making histograms, we're using continuous data. It just makes sense. So my smallest class data value is 672. My highest data value is 738. Generally, we will find a pretty number just below my lowest data value. Unless my lowest data value is already a pretty number, I usually choose something pretty. So I'm going to choose, I'm going to choose 670 for my lower class limit of my smallest bin because I want a pretty number. You don't have to use a pretty number. You totally could start at 672, but I almost always will choose a nice pretty number because I like things pretty. Okay. So I wanted a size 10. I wanted my class width to be 10. No good reason. I just like 10. We just pick a number that we like. Generally, I think I think it's between 5 and 20 bins is what we're looking for. And that number is it it could be slightly off. 20 I feel is too big. I usually won't have more than 12. Like when I'm creating my bins here, when I'm creating my classes, I usually will make my width be something so that I have somewhere between 5 and 12. I think you could probably get away with a little more than 12, but please do not go lower than 5. 5 is your baseline. 5 is the smallest number of classes you should have. And once again, it's just because it displays the data better. So here's the class widths I did. I did a 10 class width, and so I just created my bins. This one right here, this bottom one, contains the 738, so that's my last one. And this one up here contains the lowest value of 672. So I just created all my bins. I have 1, 2, 3, 4, 5, 6, 7. I have 7 of them. Good number. That's between 5 and 12. That's beautiful. So now what I did was I tallied them. I looked through my data and I made tally marks. How many do I have between 670 and 679? How many do I have between 680 and 689? And so on and so forth. I went through and I tallied them all up, created a frequency distribution, nice little table, tallied them all up. Then I also calculated the relative frequency. So I took the 2 divided by 45, which is the number of data values I have, and I did that on each of them. Everybody clear on where I got everything I have? If not, ask a question, please.
The two from.
There's if I look back at my data, I have 2 values between 670 and 679. So I have 678. Whoops, it's not a highlighter. I have 678 right here, and then 672 somewhere. 672. So those were the only
Okay.
ones between that. Yeah, perfect.
Oh, I see. So you're going back to that graph to see
Yes,
what was between the 670 and the 679, for example.
right. And then
Oh,
I
okay, okay, okay.
I did that with each of them.
Okay, thank you.
So yes, no problem. I'm sure somebody else had that very question. And then there were none of them between 680 and 689. So this looks good. I have all of my data and I have them split into bins and I have the frequency and the relative frequency. Now I'm ready to make my histogram. Except I'm going to also look at a different bin width. Let's take a look also at a bin width of 5. So now I did the exact same thing, but my bin width is now 5. So I went 670 to 674, and I did that all the way down. Now, I'm going to tell you the reason I don't like this, other than, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14. I mean, 14 to me is kind of excessive on the bins, on the graphs, but this right here is where I feel we're problematic. We don't like ugly graphs. And all of these being 0, meaning there will be no bar there, is going to make for an ugly graph. There's going to be a big gap there. I don't like that. It's really ugly. That's literally why we don't do this usually. You can have 1 or 2, you can have like back here, I have 1, but I really couldn't help it. So having 1 is not a big deal, but having 3 in a row is just going to make my graph ugly. That's literally why I wouldn't use this. I don't want an ugly graph. So let me show you my histograms. I'm gonna come back to this because I want to show you the histograms first. Let me find them. Why? I swear I had a histogram. Where is it? Ugh, I guess I didn't. I lost my histogram. I am so sorry. Okay. I apologize. I lost my histogram, but who knows where it went. I swear that I had it this morning when I was working on it. Sorry about that. We're gonna
I
do an
saw I saw one like 3 or 4 pages when you were scrolling through that looked like it was missing a gap of those three that you're talking about. Is that
I
the one?
think that that one's on the Roth IRAs. Yeah,
That
this
one.
is on Roth.
Oh, got it.
It's okay. We'll still get there. We'll still get there. You'll still get the material. I just really wanted to show you the one for the Old Faithful, and I have no idea where it went. So we're just gonna say sayonara and let it be sad and let it do its thing because I have another example. So it'll all be good. All right. So I guess we are gonna go here. So I'm going to tell you, okay, so this is fine. The lower class limit, as I said, you want it, what does it call it? A convenient number. I say the words pretty number. It says look for a convenient number, slightly lower than my lowest observation. I say pretty number. You don't have to do that, but pretty much everybody does. Now, Excel does not. Excel doesn't look for pretty numbers because it doesn't find things pretty. But if you are doing one by hand, generally find a pretty number a little bit lower than your smallest data value so that you're going to have these nice, pretty graphs. I don't even know another word than pretty. Convenient. I don't like that word. Now, this is something I don't recommend. Letting you know, I have never done it this way, but it is in our book. And so I'm going to show this to you. I have never done it this way. So if you just want to figure out, you say, I would like to have 8 bins. I want 8 classes. Then you can do it this way. You can decide, I want this number of bars on my histogram. So this says between 5 and 20. Personally, 5 and 12 is better, but just don't go below 5. You're good as long as your number of bins doesn't go below 5. But if I go into Excel and every single one of your data values has its own bin, I'm probably going to mark you down on your graph, on your lab. But it won't be a lot. Don't worry. We're still new to the Excel world, so don't worry. Okay, so let's say you've decided I want 8 bins. This is what I want. I want 8 bins. So then what you would do is you would take your largest data value You'd subtract your smallest data value and you would divide it by the number of classes you want. So my largest data value, I would take, I think it was 678. I could be wrong. No, 672. Nope. 7, go back. What number was it? What was my 738? That's the number. So 738 minus 672, and then I would divide by 8. And this will tell you what your class width could be. So it says my class width is 8.25. Okay, so then you would just, you could make it 8.25, or you could say, okay, I'm going to make it 8. And that probably would put you at 9 bins. But this is just weird, and I don't recommend it. I really don't recommend it. Do you really want your class to go from 738 to, or from 672 to 680.25? I don't think so. So I don't recommend this. Instead, figure out, I want my class width to be this and see what happens. Make sense? So I don't recommend this, but it's in your book. And so I'm showing it to you. All right. You're considering investing in a Roth IRA. So this is a bunch of data. This is if you have the textbook, if you have the soft-sided textbook, I believe it's on page 79. This represents the 5-year rate of return in percent, and a simple random sample of 40 large blended mutual funds. And we're going to do a frequency distribution, and then we're going to do a histogram. I actually really have this histogram. So this is the first one. So I made my bin width 1%. I do have 2 right here that are zeros. I have 2 right there that are zeros. This may not be able to be helped, because if I made my bin width a little bit more, I probably still would have a 0 or 1 0 in there. I don't know. Let's see how it looks. But see how many I ended up with. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Exactly 12. So let's see what this looks like when I do a histogram. There we go. Now it is not, I don't have the labels that I should. Say APR, frequency. Make sure you have these labels. And notice how I did this in Excel. Excel doesn't do pretty numbers. So there are ways to kind of tweak it to make it have the numbers you want. And I'm going to show you how to do that once we get to Excel. But this is what it looks like with having 1 as the bin width. If I made it any more, I'm going to have more zeros. So you could have made it less. If I would have made it 2, I would have had 6 bins, and that probably would have been okay. But this right here, that's ugly. I don't really like that. So you might want to go down to 2% there. It's really, I'm not going to get mad at you if you have 3 blanks. I might leave you a comment and say, you might want to go down, make your bin width wider. I'm probably not going to mark you down for that. I will mark you down for having fewer than 5 bins. I won't mark you down for having a lot of zeros, but I might give you a feedback on that and say, hey, you might want to make your bin width a little bit wider. Questions? Okay. Something important. I'm going to go to a blank screen if this will let me. I'm going to see if I can, or at least go somewhere where I can write more stuff. I need some space to write. I'm just finding a blank spot. So this, don't read what's above. When you make your histogram, I'm going to show you for reading histogram purposes. So if I have this histogram right here, and this is just making stuff up. So I have this histogram right here, and this is the way that they're going to be in My Open Math when you're doing your homework. So this would be 0. So if I put, so I put 10 here, I'm going to put 20 here, 20, so 30. Apparently I can't count. 30, 40, 50, etc. Okay. This number is a lower class limit. That is the lower class limit of the second bin. So this belongs to this bin. This 20 belongs to this bin. 30 belongs to this bin. 40 belongs to that bin, and 50 belongs to that bin. Those are the lower class limits of the next higher, like rectangle, bin, class, whatever. So that is something important. You might want to write this down. I'll give you a second to draw a lovely picture if you want to. So that is a lower class limit. We do not write the upper class limits on our histograms. You won't see an upper class limit. We're just assuming the one before it goes to 9.999 or however many decimals you need. So it butts right up to 10, but it doesn't touch it. I'll give you a second. Take a
So
break.
on the first bar there, 0 would be the lower class limit.
Yep. Zero,
Okay.
the lower class limit for that one. And your histogram might not start at 0, and that's okay if you don't have 0 of your lower class limit. And this is one of those cases where the horizontal might not start at 0. The horizontal is going to start at whatever pretty value you're using for your lower thing. So with the geyser stuff, my lower class limit here, or this would right here would have been 670 because that's what we chose. And then, uh-oh, I'm having issues. And then because we went by tens, this would be 680. So it's just the lower class limits. Is that helpful? Okay. All right, let's bump it back over here. Okay, and then I'm going to give you my my disclaimer on stem and leaf plots. I have never found a good use for a stem and leaf plot. I teach them because they're part of the curriculum. My open math might have a couple of questions asking you about them. You will not be tested on stem and leaf plots. I have never used them for any real meaningful thing, data at all. I don't find them useful. However, they're something that's been around for a long time. There's something that occasionally people use, and there'll be a couple of questions in your homework. I will not test you on it. It's just letting you know. They're not my favorites. But we're going to go into it. So stem and leaf plot, it uses, so we have the digits on, okay, let's see. Digits to the left of the rightmost digit. That is really ugly. So basically what it's saying is like 147. I have this stem and leaf right here. So I have this right here. So I would have 14 here and I'd have 7 over here. This would indicate 147. Then if I had an 8 after it, that means I have the data values 147 and 148. Then I have another one. So I have two 148s. And then I have a 9. So in my data set here, I have a 147, I have a 148, I have another 148, and I have a 149. This is the leaf. This is the stem. And you represent every single data value you have, even if it causes repetition, and you put them in order from smallest to largest. And I'm going to do a couple of those in your notes. And hopefully you'll be able to kind of read those. Okay. All right. So we're going to look at the geyser eruption data. Just a second here. I'm going to pull the data up on my other computer so that I can access it easily. Usually what I will do when I'm making one of these, if I don't have, if it's not already in order, I put these in order from smallest to largest just because I wanted to be able to create one without chaos, create a stem and leaf plot. I am not going to put every single one of these on there because this is a lot and it would take a while. I'm just going to do a few from each section. So when you are creating a stem and leaf plot of this data, I list the hundreds and the tens place on the left-hand side of the line. The reason there's two 72s here, so notice right here, notice that I have two 72s here. The reason there's two 72s is because I had a really large amount number of data values that were 720 something. So instead of making my leaf super long on the 772, I broke it in half. So I'll put 720 through 724 on the top one and 725 through 729 on the bottom one because I had so many 720s. So I'm going to get rid of the highlighting here. All right. So I'm not putting every single data value, as I said, but I'm going to put, so I have 2, 8. Oh, that's not a highlighter. That's a pen. It's a kind of weird color. That's all I have there. 680s, I have none of them. Just leave it blank. 690s, I have 5, 5, 5, 6, 8, 9, 9. 700s, 0, 2, 2, 3, 3. I'm not going to do the rest of them. I'm going to put a 9 there. I am not putting every single number here, as I said.
Where are
Seven.
the numbers coming from?
They're coming from this data. Whoops. They're coming from this data right here. So I have a 672 and I have a 678. This is 672. This is 678.
Okay.
I don't have any in the 680s, but I have 695 twice. Actually, 3 times. Did I mess that up? Yeah. No, I have 695 3 times. Therefore, 695 is represented 3 times.
Okay.
I have 696 right here. So I put the 6 right there. Does this
Okay.
help?
Thank you.
No, you're welcome. Okay. So on the 720s, I'm not even looking at the data right now. Okay, maybe I should. So I have 0, 1, 1, 2, 2, 3, 3, and then I'm going to put 5, 6, 6, 8, 9. Because I have a lot of them, I split that one up. Plus, just to kind of show you guys what it looks like when you split one. Splitting one is not ever really necessary. It's just we do that when we don't want one of our leaves to be super long. You guys you probably can see how I'm not a big fan, why I'm not a big fan of this. So one thing that's also necessary when you have a stem and leaf plot is you have to have a key. So I would put my key right here. I'm going to write the word key. And I would say, you just pick any random data value. I don't care which one you put. So I would say 71, 4 represents 714 seconds. This is your key that tells people how to read your stem and leaf plot. So 71 with the long line, this is the, I don't like this line. Let me fix it. 1 second here. Okay, there we go. So 71 line 4, that represents 714 seconds. So you have to have that key on there. I'm going to do another one, but any questions so far? I do have the chat back up also if you're not comfortable speaking.
When you make a key, do you just need to have one number,
Yeah,
or
just
do you
one
have to
data
have
value.
just one data value? So you don't have to have like 672 represents this, and then your high number 736. Okay.
You just pick any random data value. You just pick one. It doesn't matter which one. It's just showing you how to read this. It's showing you that this is 700 something.
Okay.
It's
Thank you.
because, and you'll see in a second, I'm going to do the Roth IRA data. And with the Roth IRA data, we have a decimal. And that's what I'm going to show you guys next. So actually, this isn't the Roth IRA data. Instead, this is unemployment by state. I don't even know what year this is. This is unemployment by state. So notice I have a decimal. So my stem is going to be the whole number before the decimal. My leaf is going to be the tenths place after the decimal. So my stem is going to be 4, 5, all of that. It's going to be the left side. And so this is after the decimal. So if I don't have a key, people might think that this is 28 and 38 and 47 and 68 and all of that, but it's not. It is a decimal. Also, notice these are out of order. A lot of times when I create a stem and leaf plot, I write them out of order first. I just write them down in the order that I see them. So I saw 4.7 first, so the sevens first. We don't leave them this way. You want to make them pretty. After I make them out of order, I rewrite it so they are in order. You put them from the smallest number in your leaf to the highest number in your leaf. So make sure that you put them in order. Then, of course, I need a key. Okay, then I would just pick any data value. 5, 3 represents 5.3%. So you need to have that key. Well, you're not going to be asked to create stem and leaf plots in your homework. You will be asked to read them. So it might ask you, I don't know, well, we're going to be doing mean, median, and mode in a bit, but it might ask you like the mode. So you'd have to figure out which data value do we have the most? And that would be 5.3, because look at how many times I have 5.3. Looks like I have that one more than anyone else. We'll get to mode in a minute, but it might ask you questions about how many, I don't know. I don't even know what it asks. I haven't looked at those questions in a while, but it'll have you read these. Okay. Questions on stem and leaf plots before I leave them in my dust. Okay. Let's get away from those. Shapes of distribution. These I do like. I'm hoping y'all are printing these out so you can have these nice pretty things on there. If you didn't print them out this week, I highly recommend printing out the PowerPoint starting next week. I know I talk about it a lot. It's because it is very, very helpful. I've never had anybody say they wish they didn't print them out. I've only had people say that I wish I didn't print them 1 per page, single-sided. 2 or 3 per page is good. Some people even do 4 per page, but my vision is not beautiful, so I wouldn't recommend that unless you have really good young vision. Then maybe. Okay. So when we look at a graph, we have to be able to analyze the shape of the distribution. So one of the ways we describe a graph is by its shape. So a uniform distribution is every variable has the same or really close to the same frequency. So this one is perfect. This one's like perfectly uniform. Sometimes you'll have something that's slightly off. So like, for example, this one, get the pen back on there. I could have one that's at like 21, and then, a couple of them that are up there. Maybe one of them's down here instead, but it's really, really close. Since we don't deal in absolutes and stats, we say things like approximately uniform or mostly uniform or relatively uniform. We'll use one of those adverbs to describe it. So it's really, really close to a uniform distribution. So it's basically a rectangle. This is uniform. We don't see a lot of these, but they do show up. Let's look at skew and bell-shaped. So this is bell-shaped. We also call it symmetric. We would also call it normal. Those are 3 different words for it: bell-shaped, symmetric, and normal. A uniform is also symmetric, so you need to be specific. But this is a nice, pretty bell shape. If I drew a line over top of it, tracing it, it looks kind of like a bell. This is a bell shape. This is like what we want. Most of the time we want a nice, pretty bell-shaped distribution. Our highest frequency is in the middle and it goes off and tapers off on both sides. So we have nice, pretty tails on both sides. So this is a bell-shaped distribution, or you can call it a normal distribution. Same thing. Let's talk about skew. This one right here is skewed right. It is the opposite of what you would expect it to be. The tail, it tapers off to the right. That it has like a tail on the right, therefore it's right skewed. So if it's higher on the left and lower on the right, it is right skewed. It has that long tail on the right. That is skewed right. So look for the tail. I bet you can guess what skewed left is. Bam! Skewed left, it has the peak over on the right, and then it has the tail over on the left. So I have it tapering more over here, fewer of my data values over there. Therefore, it is skewed left. I'm going to give you some examples so you can kind of guess these, see if you've got them. We're almost done with our 2.2. We're so close. All right. Shape of the distribution. You should take a look at this. Think about it in your head or even in chat or whatever you want to do. Tell me what shape this distribution is. If you said it's bell-shaped, woohoo! Bell-shaped. This is bell. Bell, it's symmetric, it's bell-shaped, it's normal, it is beautiful. Good job. I see you in the chat. This one right here. Take a look at the tail. This, yes, good. This one is right skewed. It has that longer tail on the right. So therefore it is right skewed. All right, let's do another one. I'm gonna write it on here. Right skew. Beautiful. I bet you can guess what the next one's gonna be. Bam. This one is left skewed. Thank you in chat. This one's left skewed. It has that tail to the left. It is tapers off. Most of my data is up on the right, tapers off to the left. This is left skewed. I bet y'all can guess what the last one is without even seeing it. Bam. This is uniform. Uniform distribution, a nice rectangle. It's a unicorn. I like it. I don't know if that was a typo, but that was lovely. It's a unicorn distribution. Oh, that was cute. All right. Questions about shapes of distribution. This is the end of 2.2. All right. We're on 3.1. Since I've been talking for an hour, I need to fill up my water. I'm gonna give you, let's do 5 minutes. I know you guys are probably fine pushing through. Let's do 5 minute break so that I can go fill up my water and whatnot. I'm gonna pause the recording if I can find the button for it. Okay, I don't want to stop the recording. I want to pause the recording. It won't let me pause the recording. Therefore, I'm going to be recording, but I'm going to mute it. So those of you who are watching this at recorded, I apologize, but I'm going to pause here. Five minutes. Come back at 5:58. We got about a minute. Apologize to those at home who get 5 minutes of dead air. But you can fast forward. Thank goodness for that. All right, we're at 5:58. We're going to get started. We are now in section 3.1. This isn't a super long section, and I probably wouldn't have put a break in there, but since we're going over the lab at the end also, I felt like everybody probably needed to get up and stretch their legs a little bit. I know I did. Plus, I needed more water. Should have filled it up before class. All right. So today, this section 3.1, we're talking about measures of center. So we've talked about average a lot. In life, you hear the word average all the time, and we always just think of average as adding up all the numbers and dividing by how many data values there are. But average can mean different things. Average can mean mean, median, or mode. Those are three different ways to refer to average. Now, most of the time it does end up being mean, but we also can use average with median, and I'll give you some examples in a little bit. So we've heard average miles per gallon, we've heard national average commute time, we've heard average household income, average American woman's height. We hear average all the time. We're going to talk about the three different ways to measure center, and we're probably next week, we're gonna get into more of when to use which one, even though I think I might give you a couple examples today. So let's start with mean. So the arithmetic mean, which we just call mean, we don't usually put the word arithmetic on it. We add all of the values together and divide by how many observations we have, or how many data values we have. So when we're talking about the population mean, so if I'm taking the mean of the entire population, so like the average study time of every single RCC student, we would use this symbol right here. This symbol right here is pronounced mu. It is a Greek symbol. When I write it, it's going to look like this because I don't write as beautifully as typing. It's called mu, and we take all the individuals in the population and we divide it by how many members there are in the population. And of course, this is a parameter because parameter refers to population. Now, not as cute of a symbol when we're dealing with the sample mean, we have this symbol right here. We just call it X bar because it has a bar over the top. Anytime anything has a bar over the top, we just call it X bar or Y bar or whatever. We have sample data, but we calculate it exactly the same way as the population. We just use a different symbol. And this would be a statistic because we are using sample data. So if we had a population of however many students we have at RCC, and I took 50 of them and I averaged the amount of time they studied, I would use X bar. I would say X bar equals 3.8 hours per week. It's a number I just made up. So that would be a sample mean. Now, when you're using your fancy schmancy calculator, when you're using that, your TI-83 or TI-84, it always assumes you have a sample. Therefore, it will give you X bar, even if you're doing a population. Just ignore it, just go with it, call it good. So yes, this looks really fancy. It looks scary. This right here, this symbol, it's a capital sigma. All it means is add them all up. So you take all of the values, you add them together, you divide by how many are in your population or in your data set, and then you get your mean. This is important though, when you get a decimal answer. I don't want to use that color. If you get a decimal answer, round to one more decimal place than your raw data. So if my raw data were integers, 0, 1, 2, 3, 4, 5, and I add them all together and divide by the number that there are, I would round to one decimal place. If my data has 1 decimal place, round to 2 decimal places. Now, my open math will tell you what to round to. It will tell you, but this is just kind of when you're doing your own thing, this is kind of the standard. This is what we do. Questions about mean before we do some examples? All right. So this data represents the travel time to work for 7 employees of a startup web development company. We're going to compute the population mean of this data. So I'm going to add them all up. So I'm going to do 23 plus 36 plus 23 plus 18 plus 5 plus 26 plus 43. Then I'm going to divide them all. Divide by 7. Use my fancy schmancy calculator. I got approximately 24.9. Because these were whole numbers, I rounded to the first decimal place. So about 24.9 minutes is the average travel time for the employees of the web development company. So this wants us now to take a simple random sample of 3 employees. This would be a good time for me to show you how to find random numbers in your calculator. So it's kind of cool. Let me pop over to my calculator. There I am right there. This calculator is so cool. Every time I teach this class, I learn something new about the calculator. It is a really cool thing. So I don't know if any of you have a TI-83, but if you have a TI-83, it doesn't have quite the functionality of the TI-84, but it has almost everything. And you'll do just fine in this class with the TI-83. So if I hit this button right here, this math button, and then arrow over until I get to, you see this round thing here? It has the arrows till it says prob. I want random numbers and I don't want it to repeat any outputs. So that would be right here. Rand int no repeat. What this means is it's going to give me random integers, random numbers, and it's not going to repeat any of the numbers. Now, if I went to this one right here, number 5, it would give me 3 random numbers, but it is possible I could get repetition. I could get a number repeated. So I'm going to go right here. So my lower value is 1. My higher value is 7 because there are 7 people in this company. So if I go back to my data here, so this one right here would be the first number. This is the 7th number. So it's going to give me 3 numbers to choose out of here. So I want 3 of them. The N represents how many random numbers am I looking for? I'm looking for 3 random numbers. So there we go. So I'm taking from 1 to 7, I want 3 numbers. It gave me 7, 2, and 4. So, all right. So 7. So this one's number 7. This one's number 2. And this one would be number 4. So I'm going to find the average of those numbers. 36. So this one's mu plus 18 plus 43. Then I'm going to divide by 3. So the average of these is 32.3. That would be my X bar. That 3 is really ugly. So it says to do it again. So I'm going to go back to my calculator. And I'm going to go back to math, arrow over to prob. Uh-oh, went too far. And I went rand int, no repeat. I'm going to show you just the rand int. Let's see if I get repetition. From 1 to 7, I want 3. So if I do it this way.
I have a question. I'm
Yes.
sorry. So I'm doing that, but so I'm going to random and no repeat.
Uh-huh.
but it's not giving me the option of typing in a lower upper. I have a 84 plus.
Okay, so what you're gonna do then, let me get ready. What yours probably looks like this. Hold on, let me paste this. What you guys don't realize is this calculator does some really good copying and pasting. So if you arrow up and highlight and hit enter, it pastes for you. So you would just put
Oh,
like
nice.
this. So you're gonna put, it probably gave you a parenthesis, correct?
It did, yeah.
So your one would be your lower value, then put comma, and then 7 is your upper value, comma, and then 3 because you want 3 out, and then close your parenthesis. And then if you hit
Oh,
enter,
gotcha.
you get 3 numbers. Perfect. That was a great question. I'm sure someone else here has the same calculator issue.
So I did that. I
Huh?
just did that, and it popped up with an error.
Okay.
It
Um,
didn't give me three random numbers.
okay. So did you remember the commas?
The commas are in, and the parentheses are in.
You have 1 comma 7 comma 3,
Correct.
and you closed your parentheses. What kind of an error? What does it say?
It says error argument, and then
Mhm.
it gives the option of quit or go to.
And you did 173. Let me Google this real quick. So you have the TI 84 plus?
Correct.
See, normally I don't Google calculator functions during class, but I'm assuming other people have no repeat. I'm sure assuming some others have the same calculator. That's why I want to let's see what this says.
I have the same calculator, but I can't even find the comma. Oh,
You,
wait, never mind.
you
Found it.
found it? Okay. Okay, that doesn't help me. That's a weird developer thing. How to use the rand int no repeat. So it says to do, so it shows like this. It shows, oh, this is just the rand int, and it shows do 1 comma 6 comma 3, so 1 to 6 and choose 3 of them.
Mhm.
And you did it that way, and it gave you an error. Does yours
Correct.
look like this except for it says no repeat? Does it otherwise look like this?
It does. Yeah, yeah. 1 7 comma or
1
one
comma
comma
7 comma 3
three
parentheses.
close parentheses. Yeah, error argument.
Error argument. Okay, so I might have to dig into this a little bit more. Try it with the rand int without the repeat and see if it'll let you do that. And it could be,
Looking at-
go
Mine
ahead.
doesn't seem to have the no repeat. It only goes up to 7, and I can't get to the no repeat one.
Yeah, some of them, what calculator do you have?
TI 84 plus.
Okay. So I don't know if this is going to work for you, but I
Hmm.
troubleshooting here. So if you hit,
Um,
yes.
I don't mean to interrupt, but I tried the rand int and I
Uh-huh.
typed in just like you said, and it worked. It
Okay.
gave me a 7, and a 2.
Oh, good.
That's what I got. I got 772.
It's
Me
because
too.
so you'll all get the same thing because you haven't seeded it. Um, so random isn't random. Just letting you know. Random is not random. Calculators use an algorithm to spit out random numbers. So unless you do something called seeding, everybody will get the same random numbers. So we will go in and we will say, we will tell the calculator when you start your algorithm, start from this number. And we put a random number in and it'll seed the calculator. So then you're going to get your own unique random numbers. But because we're not like competing or caring whether or not you guys get the same random numbers right now, we don't have to seed it. But seeding your calculator, if I was doing a class of 30 kids and I wanted everyone to get different random numbers, I would have them seed it with their telephone number because we're all going to have different telephone numbers. And it helps them all to get different random numbers. So I'm assuming that your calculators have never been seeded, and that's why you're all getting the same thing. So you should, those of you who have a TI 84 but don't have the no repeat one, if you hit second 0, it pulls up a catalog. And I just didn't hit the second button. Pulls up a catalog and it has so much stuff in here. And if you just go down pretty much. I'll go all the way down until we get to the R's. It should have rand int no repeat. If not, then you're just going to have to use rand int. And yep, so if you go to rand int no repeat and you hit enter, then you can use it. But or just use rand int, and you might have to do more than 3. Just ignore the repeats. Ignore anything that repeats. And so then now I can put 1 comma 7 comma 3, close my parentheses, and get my numbers.
So mine wasn't working that way, like with the 173, but I just took out the 3 and did 1 comma 7 and it started working.
And it just gave you one number.
It gave me 5 numbers.
Oh,
Or
and
yeah.
then you
I
just
don't know.
chose the first 3.
Yeah.
Okay. Bradley, can you try that? Try it without the 3 on the end. And see if that works for you. So if you don't have the no repeat and you don't want to deal with the catalog, if you just do the with the repeat and just throw out any of them that are repeats, like I still don't have repeats, but throw out any that are repeats, you might just have to do it twice.
Okay. Yeah, I deleted the 3 and it gave me 4, 7, 6, 1, 3, 5, 2.
So you could just choose the first 3.
Okay.
If you were doing random numbers. So this leads me to, and I know that we're not quite at the lab yet, but if you are for completely at a loss for discrete data, you could go to the probability here and just go random numbers. Well, we don't want those, but just random integers. I can do random integers and say like 1 to 200 and just do one at a time probably. And then just do these until I get 20 numbers. You could always do that if you wanted to. If you don't have discrete data for your lab, you could just do this until you get 20 numbers and put those in. And it's kind of boring, but I don't really care what your data is. I don't. I mean, I love interesting data, but if you're at a loss, hey, go for it. Do this. All right, let's go back to the lesson. All right, so every time I get random numbers, so I'm just going to choose 3 other ones. If I chose 3 different random numbers here, so let's choose these ones. Let's pretend those are random, and I have 36 plus 18 plus 5. This is going to be an X bar again. Oops, I didn't divide by 3. Now have 19.7. Obviously, the population is much, much more accurate. So this kind of shows you that when you're doing an experiment, sometimes you have to take a lot of different samples in order to get a picture of what things really look like. Population is always better if you can use it, but sample mean calculated exactly the same way, you're just using sample data. I know we spend a lot of time on the calculator, but you'll be thankful because I want you to be comfortable with your calculator. We're going to be using it a lot this term. So TI-84s, I am pretty well versed in. TI-83s, kind of, sort of, but I can figure them out. If you have a TI-89, I don't know very much at all, and Google will be your friend. Every once in a while, if someone comes in with a TI-86, Google will be your friend. All right, moving on. All right. So I would like you, with your own fancy schmancy calculator, to compute the population mean of these test scores. So there's 10 test scores here. So go ahead and calculate the mean of these test scores. Pretty sure I know what it is, but yeah. right, yes. Your mu equals 79. If you're not comfortable trying to write a mu, if you just write mu, that works also. The word mu spells mu, so if you don't want to try to draw this lovely mu, mine never is lovely. All right. So now, and I'm only going to make you find one sample. So randomly get 4 numbers. Choose 4 of these. I would in my calculator do random, no repeat, 1 to 10, choose 4. You do what you need to do to get 4 random, and then calculate a random sample. There are 10 of them, so you want to do 1 through 10.
And those 4 random, you would write that as X bar equals
Yes. I just didn't write it
your
out.
4 randoms divided by 4. Oh, it's right there. Sorry.
Yeah. Use X bar because we are doing a sample. Notation is very important. I'm going to get rid of the one after because it's annoying me. Happens. Let's go ahead if you want to say it out loud or type it in chat or whatever you want to do. Would love to see what your averages are, what your sample means are. Got a 75.5.
79.25.
Okay. We'll go 0.3 since we have integers. 80.3. Now, these are all over the place because they're samples. That's what happens when you're using samples. And I mean, 80.3 and 79.3, those are pretty close to pretty close to, sorry, the 79 that we got for our population, but 75.5 is not super close. The 83 I got is definitely not super close. So when you can, obviously, when you can use the population, use the population. Okay. So finding the median. So you probably have heard in the news talking about median home prices. Median is used a lot in like real estate. Anybody who's ever, 81.3, we got another one. Good. So anybody who's ever worked in real estate, you've heard a lot about median home prices. Median is the center of your data set. We arrange the data from smallest to largest, figure out how many observations you have. Then you choose the data value in the middle of the data set. The very middle observation is your median. So it doesn't matter that you're not dividing by anything. Well, you will, you'll see in a second, but you just find the middle value. So then half of the data values are below and half of the data values are above. So you just choose that middle value. So here we go. So here's my data set. This is the same one we used before. Now I'm going to tell you, I am really bad at arranging data from smallest to largest. This is not one of my skills. So I have 5, 18, 23, 23, 26, 36, and then 43. So you make sure you arrange them from smallest to largest before you find your median. So there are 7 data values. Therefore, the 4th one is the median. This is the middle number. So this right here is the median. We do not have any fancy symbol for median. In your calculator, it'll say MED. I think my Open Math uses it also. It's usually just MED. There's nothing fancy. It is just the value, 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 the So when we are looking at median home prices, it would be the value of the home or the price of the home smack dab in the middle of all of the data if we went from smallest to largest. So that's median. Questions before I move on? All right. So a new employee arrived at this company, and they have a 70-minute travel time. So now I'm going to rearrange these once again, smallest to largest. But now I have 8 data values. I can't just circle the one in the middle because the middle is in between here. The middle is right in there. So what you do is you average those two values. You find out what is smack dab in the middle of those. So I would do 23 plus 26 and divide it by 2. And I know I could do this in my head, but sometimes I don't trust myself. So that's 24.5. So now the median is 24.5. This is my median. So the median doesn't have to be an actual data value. It just has to be smack dab in the middle of your data set. So when you have an even number, it is smack dab in the middle. Questions? Because I'm going to make you do this on your own. Median is like one of the easier ones. Probably the easiest math you're going to do all year. All right. So this table represents the length in seconds of a random sample of songs released in the 1970s. We want the median length of songs. I will put these in order, probably poorly. I will put these in order, but then you're going to find the median. Let me see. My lowest value is a 201. Probably going to demonstrate right now how bad I am at this. I almost always forget one. See, I did 179. See, thank you. Uh-oh. I don't know why. I just can't have like a blindness or something when it comes to that. I don't count well either. Students at the high school love to pick on me, about the fact that I don't count well. If I'm handing out papers, I always hand out the wrong number. I'm running out of room, so I'm going to go down below. And there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There are 9 there. So go ahead and find your median. Good job. You are absolutely right. It is the 5th one in because there are 9 data values. So now there's 4 below that value and there's 4 above that value. So that is smack dab in the middle. Questions? Because now we're going to do an even number. Increasing the difficulty. I have one fly in here and it's driving me crazy. Okay. All right, now we're going to use the test scores. I'm going to write them down at the bottom. I'm going to get smart here. Maybe I'm getting smart. Let me see, 62. Okay. Let's go ahead and find the median. Yay, good job. I'll give everyone else a second before I reveal. So obviously has to be between these two because this is halfway. And then you would do 77 plus 82 divided by 2. So your median, 79.5. Questions, comments, queries, concerns? Feeling okay about median? I'm only giving you the easy math today. All right, we are really close to done. We're on 44 of 57. Trust me, this goes quickly. All right, next slide. So this is, you might want to, what was I going to say? You might want to like bookmark this page. There is a question that you're going to get, and it's, I don't think it's, I think it's on lab 2 that asks you to compare your mean and your median and determine the skew based on a comparison of your mean and your median. So you might want to kind of bookmark this page. So if the mean is less than the median, we are skewed left. If the mean is greater than the median, you're skewed right. If they're roughly the same, if they're really close, then it is symmetric. It's bell shaped. I'm going to write bell shaped. I mean, it definitely could be uniform also, but we use uniform so rarely. So like, for example, back here, our mean, the mean was 79 and my median is 79.5. I would absolutely say that that one's bell shaped because those are so close to each other. Now, if my median was 84, then I would say that it was skewed. But because they're really close, I'm going to say that that's symmetric, that that's bell shaped. I'm going to give you a second if you don't have it printed and you're writing this down. All right. Okay, so don't worry, I'm not going to make you find the mean, and or actually we will because I don't think so. Wait. I ordered them smallest to largest. We're not going to add all these up and find the mean. These are asking prices of homes in Lincoln, Nebraska. So we're going to find the mean and the median, and then we're going to compare them. So I put them in order from smallest to largest, but I found the mean and the median for you. So the mean asking price is 168,320. The median price is 148,700. So my mean is greater than my median. So is this, well, it's definitely not symmetric. Is this going to be skewed right or skewed left? My mean is greater than my median. Let's go back and look. Woo. Let's go back and look. My mean is greater than my median. You're right, it's skewed right. So let's take a look at the histogram. So see this lovely histogram? You can see that the tail, oops, that's not a pen. See that the tail over here is on the right. So this is definitely skewed right. So we have more homes that are lower priced than we do the higher priced homes. This is where the skew comes from. Okay. We're going to do this with birth weight now. So we have 50 randomly sampled babies. We're going to find the mean and the median birth weight. We're going to talk about the distribution, and we're going to talk about which center we want to use, whether we want to use mean or median here. So here's my histogram, and you can see that my mean and my median are right there in the middle. I snapped this from the textbook. I couldn't find this page on the digital textbook, so I just took a picture. So the mean and the median are both in that center, the center bar of my histogram. They're very close in value. So this right here is something you're going to write down. If your mean and your median are really close to each other, if you have a symmetric distribution, you want to use mean. So this is what it says down here. So when they're symmetric, I'm gonna have I have a table coming up that'll help you. Use mean. Kind of like the orange on there. Skewed.
Did you say if mean and median are symmetric, use mean?
If mean and median are really close to each other, use mean. If they are not, if we are skewed, use median. And I have a table, a chart coming up in a couple of slide or a few slides away that has all of it nice and pretty together. So if we have a nice symmetric distribution, use mean. If it's skewed, use median. Outliers tend to drag your mean around. It affects it greatly. For example, if they were talking about, yeah, the average salary of the employees at this company is really high. It's $150,000. And all the employees are like, but I like make, $40,000. What are they talking about? Well, if your CEO is making $1 million, it drags that mean up there and it makes it look like everybody's making more. They do that with teacher salaries a lot, where they say like the average educator salary in Oregon is $120,000. Well, they're including administrators in there. And so if you're looking at mean and you're including administrators, it makes it look like teachers make a lot more money than they do. If they used median, it would be very different, which I don't know what the median salary is at all. Okay. So mode. This one is short. Your husband is a teacher. So your husband knows, he understands. Struggle is real. All right, so the mode is the most frequent observation of the data set. It is the one that occurs most frequently. You can have no mode, you can have one, you can have more than one. If there's nothing that occurs more than once, you have no mode. If you have two modes, I love this word. I'm just going to give it to you because I like the word. It is bimodal. That's two modes. I just like the word. If you sit there right now and say bimodal to yourself, you'll like it too. It just feels good saying it. I know I'm weird. I already told you I was weird. I'm just confirming that. So we have a data set right here of vice presidents. I don't have Kamala Harris on here because my graph is nice and pretty and I don't want to add just one more box. So this tells you the state of birth of all of the vice presidents through Mike Pence. And we're going to find the mode. You could find it looking at the table, but it's going to be easier once I put it like this, it's not raw data. So you can see that I have 8 vice presidents from New York. There's 8 of them born in New York. Therefore, the mode is New York. Because if I had 2 of them, let's say that just because it's easy to turn it into an 8, let's say I also had 8 on Massachusetts, then Massachusetts and New York would both be modes and we would have a bimodal. It would be bimodal. Questions about mean, median, or mode? I have one slide left that wraps it all up. All right, this is it. This tells you when to use which one. So for mean, if we have either quantitative, if the data is quantitative, well, they're all quantitative, well, except for mode. If the data is quantitative and we have a roughly symmetric distribution, use mean. For median, if it's quantitative and we are skewed either left or right, use median. If we have qualitative data, qualitative/categorical, if our data is not quantitative, we will use mode. Or if you want to know which thing shows up the most, then you would use mode. We don't use mode a lot. That is the end of the slideshow. That is the last of the new material, not the lab. We'll still do the lab. That is the last of the lesson. Any questions on the lesson before we move on to the lab? So the homework for 2.1, 2.2, and 3.1 are due Monday. The lab's going to be due Tuesday. It's FYI. All right, let me swap over to Excel. Okay. So your lab, to get to the lab, let me first get you there. So when you open the lab, I know I'm on a different screen than you guys have, but when you get to the lab and you open it up, there's a file right here that you will download. And then after you do your lab, you're going to save it on your computer, and then you can upload your file. Just find wherever you saved it on your computer and you can upload it. I prefer if you save it with your name, because when I open them on my computer, sometimes I will lose whose is whose and I have to close everybody's out and reopen them. But if you don't, you don't. It's not that big of a deal, but I would love it if you saved it with your name. It just makes it just a little bit easier for grading. So once again, here is the lab. So as I said on Tuesday, you're going to need 20 data values of each categorical, continuous, and discrete. Categorical, it could be something as simple as opening up a bag of M&Ms and randomly getting 20 of them out and looking at the colors. I want your raw data. And please tell me what your variable is. I put favorite color right on the top here. And then what I did was took 20 random people, 20 of my Facebook friends, and asked them their favorite color. And I typed the colors down here. So this is just raw data. I haven't done anything with it. I haven't cooked it yet. So I just typed all of that in here. Over here now, I organized it. So I put down all of the colors and I counted how many people have that as their favorite color. And I just put them in this table. I created a frequency table right here. So there's 5 people that have green as their favorite color, 7 have blue, 4 have red, and so on and so on. So I just organized it. I'm not going to do the graph yet. We're going to talk about the questions. Question A, what is my population? Think about what population is. Population is my Facebook friends. Population is not my friends' favorite colors. That's going to be my variable. Population is the group of people I am studying. I am studying my Facebook friends. They gave me their favorite color, but I'm studying my Facebook friends. B, what is the variable you're studying? Here I would type favorite color. You do not have to answer the question, why are you interested in this population and variable? I don't care if you're interested in it. You don't have to be interested in it. Don't answer that question unless you really are interested. Otherwise, just tell me what variable you're studying. I'm studying my, it's just my friend's favorite color. Most of the time, categorical will not have units. So you can just type NA or no units. It's categorical, whatever you want to do. Why am I sure my sample is categorical? This is where you are going to rely on the definition of categorical. You're going to look back in your notes at what a categorical variable is, and then you will say, this is how I know it's categorical. I want you to look at the definition and apply it to the data you have. I know it's categorical because insert thing here. Where did you get your data? And I don't care how it represents your population. I don't care about that. All I want to know is where did you get your data? I asked my friends on Facebook. If you got it from a website, either give me the link or the name of the website. So you can say census.gov if you got it from the census, or NFL.com or whatever, wherever you got your data. I want to know either the website or ask my friends on Facebook, how did you get it? All right. We're going to do a pie chart. This is going to be lovely. All right. So I'm going to highlight both of these columns right here. So to highlight it, all I did was click on the green with my button down. I just dragged and I highlighted it all. So I'm highlighting all of those, both of those columns, not the X and the F, just these columns. Now I'm going to do insert. If you go to recommended chart, most of the time it will recommend the chart that is best for this. See, it recommends a pie chart. You can also look here. There's a pie chart little button right here. Just go to recommended. It'll give you a pie chart. I'm going to move it. All I did was clicked on it and dragged it. And I'm going to make it, I don't care if it really fits perfectly in the box, but I'm weird like that. I like it to fit in my box. All right. You must have a chart title.
I have a
Favorite?
question.
Yes.
Sorry, is on our folders, is there a template for this Excel? Or
Yes.
are we making it from scratch?
No, this file that you're downloading right here, this is exactly what I have here, just without data in it.
Okay.
Yeah. So the only difference is it's not going to have this data in it, and it's not going to have these words that I typed in. So yes, you have a
Okay.
template. If you just download the lab, it'll have that template there. It's a good question. I'm
Perfect. Thank you.
sure others were questioning that. Okay, so if you really want to annoy me, you can leave it, and you have colors. You can leave the purple is blue, the red is green. That's kind of annoying. So if you double click, so I just double clicked on my pie graph, and I got this lovely little this thing right here. So I'm going to click on this one right here, and I'm going to change some series options. And I think I did it wrong. Oh, no, there we go. Fill. Okay. So this one right here, that one's supposed to be blue. I'm going to change it to blue. This one right here is supposed to be purple. I'm just clicking on them and then just changing the color. So I click on this one right here. That one was supposed to be purple. This one's supposed to be green. So I'm clicked on this and it's supposed to be green. So over here where it says colors, I want that one to be green. This one right here is supposed to be purple. Over here, change it to purple. This one is supposed to be brown. That's kind of ugly. That's my sister, by the way. Her favorite color is brown. She's really weird. But she's like, I don't even know how to make it brown. She's super smart, though. Okay, that's close enough to brown. Okay, and red. My sister's a doctor. She's a doctor of Chinese medicine. She's finishing up her doctorate as we speak. All right, so something I want on your pie graph, I want percents. So look up here. So up here, you have all sorts of fun options. I want you to play with these and find something cool. So I'm going to click on this right here, and I totally forgot that it will change your colors. So all the work I just did to change those colors, it just undid it. So that is your lesson here. Change your colors after. So choose whatever format you like and then change your colors, because now double click again and I would have to fix them all. I'm not going to fix them all again. You get the idea. All right. I want you to play with it. Have some fun with it. Choose some things that are fun, but I want the percents, and you have to have a title. All right. Questions on categorical before I move to continuous? All right. Continuous data. My continuous data is the magnitude of the largest earthquakes by country. So these are all my continuous right here. Once again, put your raw data in this column. My population is countries of the world. It's not even earthquakes, countries of the world. It's just countries of the world. I am studying countries of the world. My variable is earthquakes, is earthquake magnitude. So earthquake magnitude is my variable. I don't care why you're interested. Unless you really are, feel free to tell me a story if you'd like. I don't care if you're interested. Most continuous data will have units. Could be temperature, so it'd be degrees, it could be inches, it could be miles, it could be feet, it could be ounces, grams, whatever. You're going to have units. Refer to the definition of continuous to tell me why you know your data is continuous.
I have a question.
Yes, go ahead.
Sorry. For the units of data, for the data that I compiled, it's hours and minutes. So that's okay that it's two things?
Yes. Yes.
Okay, cool.
Yeah. Okay. Where did you get your data once again? I want to know where you got your data. If it's a website, give me either the website name or the URL. If you polled friends on Facebook, tell me their names, or not their names, tell me that you polled friends on Facebook, whatever. Okay, so now let me tell you, this right here, I'm going to highlight it. You do not need to fill this in. Since I created this lab, the way that Excel does things has changed. So you don't need to do this piece right here. I mean, if you want to, go for it, but you don't need to do this piece. I want you to tell me your interval width, but don't do this piece right here. All right. I'm going to show you how to make your histogram pretty. So I'm going to highlight. I have a lot more than 20. You only need 20. But I have like a whole bunch. I'm extra. What can I say? Okay. So I have a whole bunch here. And once again, go to insert. The recommended chart will probably give you a histogram. Here's mine. If it doesn't, you can click on the little histogram here and choose it. The recommended, though, usually will give it to you. This is lovely. I'm going to make it bigger so you can see what's going on in a second. Okay. Mine already has 1, 2, 3, 4, 5, 6. Mine has 7 bins. This is not what I want. But before I do anything, because we saw how as soon as I started making changes, it messed everything up. So I'm going to, if I want to change my color scheme, I'm going to do that first. Choose the histogram I like. Choose whichever one I like. Make sure I do that first. I don't like that one. Okay, we'll do this one. Make this a little bit bigger so you can see what's going on. That's a lot bigger. You need titles. So watch. The chart title's already there. So see over here where it says add chart element? Click on that. I want axis titles. I want a horizontal. Axis titles. I want a vertical. My axis title down here would be magnitude. My vertical axis right here will be frequency. We should all have frequency as your vertical axis title. All of them will say frequency. Greatest magnitude of earthquake by country. There we go. So now I have my titles here. Now I'm going to mess with my bin widths because this isn't what I want. I want 0.5. So I'm going to double click on that and go to my options. That should not have done that. I must have double clicked in the wrong spot. Sorry. Double click out here. Did that work? You know what? It's like okay, there we go. All right. Double click on the actual the bars of your histogram. Double click on the bars of your histogram. It's going to automatically show auto on the bins. I don't want auto. I want bin width. I want 0.5 as my bin width. Now that I have 0.5, it gave me all of my bins. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 bins. That's lovely. I like 10 bins. If you wanted to change other things, like let's say I want it to be weird things, I want patterns on there, you can change stuff over here, but some of it is very strange. So I don't even worry about it. All right. Now, we talked about pretty numbers. You can save drafts. You can save as many drafts as you want, Alex. You just upload your final one. So save it on your computer, and then when you're all done and you have it pretty, then just upload the final one. And let's say you uploaded the final one and then you were like, oh no, I did something wrong. I need to redo it. You can retry the assignment up until the due date. You can retry it as many times as you want. I will look at the last one you upload. Does that answer your question? Okay. So remember I told you that we can kind of tweak things? So I wanted, remember pretty numbers? Remember pretty numbers? I really want my lowest bin to start at 4, and I want them to each go up by a half. So usually what I will do, now this is kind of cheating, but I will allow you to do it. I'm going to type what the actual lowest number is right there because I want to remember. I'm going to change my lowest number to a 4. Once I do that, I now have pretty numbers for my bins. Doesn't that look much better than the ones that they gave me? I will allow you to do that just because, I mean, aesthetically, it's more pleasing. And, you know, we would do this in real life. If you were creating one by hand, this is what it would look like. Just make sure you keep track of the data value you replaced if you're going to do that. Now, you don't have to do that. I'm 100% okay with you leaving it at the unpretty number. I'm just weird and I like pretty numbers. I'm going to change this back, not pattern, because this is annoying me. Solid fill. Okay. Ooh. Okay. Anyway, so you do you. Questions, other questions on the continuous before we move on? The discrete will take all of 3 minutes. Okay. Discrete data. My discrete data is imaginary friends on Facebook again, how many children they have. Remember, discrete data is numerical, it's quantitative, and it can't take on any value. Usually it's integers. So if you were looking at, if you collected 20 bags of fun size M&Ms and you counted how many M&Ms are in each of those bags, those would be discrete. If you did random integers on your calculator 20 times, those would be discrete. Counted, counted did the score for the last 20 basketball games of a certain team, that would be discrete. So once again, what's your population? What's the variable? There's probably not units. There might be, but there's probably not units. Look back at the definition of discrete. How do you know it's discrete? Same thing here. Where did you get your data? So I want you to do whatever graph you want. I want you to play with it. Use whatever graph you want. So try to figure out what graph makes sense. You could do and I don't care if you use one you've already used. I probably would use a bar graph for this particular thing. I don't like those bar graphs. There we go. I would probably just use a bar graph. Maybe not. Maybe I would do a histogram. I don't know. Nope. That turned out weird. I don't know what happened. Oh, I see. If I did this right here, that would be my bar graph because I'm silly like that. So see, I have some weird bar graph. Anyway, I'd probably do some sort of a bar graph. You could do scatter plot. You can do whatever you want. I want you to play with it. Try the different graphs. Actually, that's probably the better idea. Let's do this. Pie chart. That's actually really cool. Okay. Whatever graph you want. I don't care if you reuse one you've already used. You can do another pie chart. You could do another histogram. I don't care what kind you use. Use whatever you want. But this is where you play. This is where you kind of have some fun with it and with fewer rules. All right. That's it for the lab. No, you can't do a pie chart for continuous. Continuous has to be a histogram. You could do a pie chart for categorical and discrete, but the continuous has to be a histogram. You thought you were going to get off easy with the pie charts for all three. No, histogram needs to be for the second one. Now, if you are still confused and you want to re-watch instructions, there is an instructional video for this lab also. So if you waited a couple of days and you forgot, you don't have to fast forward through this entire lesson. You can go, there's a video specifically instructions on this lab. And if anybody's confused or you're working on it and something's wonky, send me an email, send me a message. You can attach your, if you need to attach your spreadsheet to me, your Excel file to me and say, I'm really confused, what went wrong? I'll try to help you. All right, other questions? So these are questions. We are still being recorded. All right, I'm going to stop the recording.